You saw that? We just renamed the talk. So the talk is going to be 12-factor apps. The reason why I made this adjustment, talking about gRPC, I think it's a little early for that kind of optimization. So what I want to do is talk about like apps and how you need to build them in order to take advantage of all the things you've been learning about the last day and a half. So I'm going to be doing it on things, what I call the HashiStack. So I'll be using Consul, Volt, and Nomad. And the goal is to put all three of these things together and see what it takes to actually write an app that can use them directly. So I won't be using Consul template. I won't be using anything that makes it easier to take an existing app. What I want to do is show what happens if you buy all the way in. What does your app need to look like, OK? The other thing we need to know is that I'm running all of the new versions that they announced yesterday. So if things don't work, it's probably a bug and not my fault. There's not going to be very many slides. I promised someone yesterday that I would have about 5 slides, so I'm going to stick to that. All right, so it's funny that we're at a conference about infrastructure and scale and all those things, but most people actually have this, right? This is what most people have. Like, if you have this, raise your hand. Right, see, that's the real life. Like, you come in like, I want to talk about scalability. And I say, what is your infrastructure? And they're like this. Like, you can scale that on your iPhone. So, but we'll just work with it, right? So what do you need to do to take that and use it on top of the HashiStack? To me, I think 12-factor was kind of the kickoff point. So how you write your app, some of the principles outlined in 12-factor really resonate well with things like Nomad that want to schedule your applications on various machines. And also this idea of having your configuration be dynamic. So instead of putting it in a file and having the static config that you push around, the idea would be your application launches, and it grabs its configuration for the environment. Now, in 12-factor, that means getting them from environment variables, right? And that's not really realistic, in my opinion. I think in the environment variables can be used to pass around necessary tokens, let's say to talk to Vault, and maybe grab other configs. We've seen in some of the things around Vault where you can do things like get dynamic credentials for your database, and we're going to show some of that stuff today. So 12-factor apps, I'm going to show you a little bit of the application that we'll be using. I won't do a deep code walkthrough, but I will show you the application. So the application is called HashiApp, right? It's on GitHub if you want to look at the details. But we're going to do just step through a little bit of the code so you can kind of see some of the logic. It's written in Golang, as all applications should be. If you're not writing in Golang, that's a problem. I'm not biased. All right, so one thing that is most important to me is like log messages. For some reason, people don't like to write log messages. One of the most important log messages is that your app is actually starting. Have you ever seen a sysadmin that deploys the app and has no idea what's happening? Is it starting? Is it crashing? So that first log statement does wonders to make people feel confident. I must have done something because your app is starting, right? So this is important. The next thing that I'm doing here is I'm going to be using Vault for my secrets. And I've talked to all the people that work on Vault, and there is no better way yet until we have native integration between Vault and Nomad. So until then, you're going to have to pass in your secret in an environment variables. Now, the ramification for this is if you have a Nomad job spec and you put your Vault token in there and you put it on GitHub, you will be on the news in the bad way, OK? So don't do that. So we're going to do this here, and we'll talk about how we're going to manage that going forward. And then here, I'm basically having a client that goes out and connects to Vault for me so that I can interact with Vault. My application generates JWT tokens for people that authenticate so you can use it in a subsequent request. And just so you know, this is a monolith application. It's OK to have monolith applications. They work just fine. Adopting these tools do not require you to move to microservices first, OK? You still can get a lot of benefits out of this particular stack. Here I'm grabbing my secret from Vault for my JWT to be able to sign the tokens. And also I'm going to use dynamic credentials here. So I'm going to go out to Vault and read from this MySQL creds HashiApp, and I'm expecting that to return a dynamic credential for me. And once I grab it, I will initialize my database pool using the credentials that I get back from Vault. So at startup, every application instance will have their own username and password to the database, and Vault's going to manage that for us. I'm just going to ping the database here. This is just an example app just to make sure that it's up. And then I'm going to, instead of binding to an HTTP port on my own, I'm going to assume that Nomad is going to inject the right port as I start up, right? So I'm going to pull my port from the environment and bind to it. The rest of this stuff is just me exposing various endpoints for my app. One of the most important endpoints is my help Z endpoint. So I would like a way to health check my application. So instead of running a bunch of scripts, Nagios checks, and those things, I'm just going to expose one health endpoint, and I'm going to be responsible inside the app to verify that everything is healthy so no one has to build anything around me, right? So this will be nice with a Consul integration. The other thing that I'm going to do is renew my credentials in the background, right? So once my application is running, I'm going to spawn off a separate grain thread go routine to renew my database credentials on an interval, okay? The other thing that I'm going to do is make sure that my app shuts down cleanly. So when Nomad is running and you ask to stop a job or shut down a job, your responsibility is to shut down cleanly. Most people do not do this, right? I look at many people's code bases and they just crash. Stop, done, in the middle of database calls. So handle those things cleanly. So here I'm watching for errors, or I'm watching for signals on the channel, and I'm going to exit cleanly, and I'm also going to close down and finish up my last HTTP request, okay? So this is the app we'll be working with. If you're interested in all the details of how this is wired up, the application is on GitHub. In this talk, I will be using binaries for my workloads, right? So I won't be wrapping them in any other packaging format. I'm just going to be using the binary that I get from my build tool, okay? So that's that application. All right, so that's the 12-factor app we're going to be working with. So it's self-contained, has all of its dependencies. We don't need any files, and it can be deployed as a single binary. And we're going to use Nomad to manage that for us. So this is what the stack looks like for most people. You go to a conference like this, you go back to work, and you start changing things, right? We're not running enough of the HashiStack in my organization. So you start to try to find a use case for these things. So to me, I think from what most people are afterward, of managing an application, I think the three things at the top, a Vault cluster, a Consul cluster, and a Nomad cluster is good enough for managing your application, whether it's microservices or a monolith. I think you can get a lot of value of just those three pieces. And down here on the worker nodes, Nomad is really flexible. It's one thing that I like about Nomad. We don't have to run a particular workload. In this case, we get to actually just run a static binary, which I find unique to this particular platform, which is kind of nice. And this is just what our worker load looks like, our worker nodes look like. It's pretty simple. You don't need to get too complex here. The other things that I have here is also I'm using the DNS from Consul. So I do have DNS masks running on all of our servers, and we'll look at how those are set up in a moment. This is what most people think that they want to do, right? So when you look at this stack, people say, what is it optimized for? Why do we introduce all of this complexity? Why? A lot of people do have situations that look like this, right? You have a bunch of services here. I won't use any buzzwords in this talk. I'm refraining from buzzwords, right? You just have applications that happen to be smaller than your monoliths. That's how we're going to describe those. And then batch workloads, right? So you have these workloads that you want to do on demand. When you have this kind of setup, these tools really shine and soon become a necessity, right? So you can brute force the other case, but this case is really hard to brute force, right? You guys ever heard of the meat cloud? Right? So the meat cloud is where you have a bunch of humans, and you hire more of them, so that way you can run and manage more applications, right? When people have automation, they just use a cloud platform. But when you don't have any automation, you hire more people, and then you have the meat cloud, right? So now you learned the new thing. If you have the meat cloud, don't be ashamed. Now you know what to call it, so when you're in a stand-up, it's like, are we doing meat cloud? Change it. All right, so what we want to do is just get back to reality, right? So this is what most people have, okay? Can we get value out of this? All right, so let's see what it takes to manage and deploy this application. Remember, self-contained, we're going to get our secrets from Vault. We're going to get our configuration and service discovery from Consul. And then there's this other issue of, now that we're using Nomad, and we start to scale or have multiple copies of our web application, how do you find them all? How do you actually get traffic on top? Most people skip over this part, so we're going to see what it takes to actually get traffic to all of your workloads once they're running. All right, that's the last slide. All right, guys, this is where, if you work on Nomad, raise your hand. All right, so I know where to look. If I get into trouble running Nomad RC release I'm going to look in your direction. Yell out some help, okay? All right? You asked me to run the RC, I'm running it. So the first thing we need to look at is to make sure some things are healthy. So we do have part of my cluster setup. So we do have the Nomad already bootstrapped. If you want to follow along on this setup, I do have everything here on GitHub. So everything I did to provision my stack is here. So if you want to follow along after the talk, feel free to use this. And here's my cheat sheet in case I forget something, but I'm going to try to remember things I need to do. So we have Vault running. We have our initial Consul cluster. Vault is unsealed. And you can see that it's unsealed because in a new version of Vault that was announced yesterday, Vault will automatically come up and register itself with Nomad. And this is actually nice because now I no longer need to pass in the URL to my Vault server on my app. And the nice thing is once you unseal Vault, it also registers itself and says that it's unsealed. So it's eligible to be actually the master, which is kind of nice. So if you don't unseal a couple of them, their status will actually be failing here. We have our 3-node Nomad cluster, and again, Consul. So this is our initial stack, but now it's time to get our application. So what do we need to do first? So what I'm going to do is log into, where am I? So I'm going to log into my control stack, one of the nodes. So this is my 3-node cluster with Vault, Consul, and Nomad. And we're going to make sure that we don't have any jobs running. Make sure I cleaned up after myself. All right, so we don't have any jobs running in Nomad currently. Is this font big enough for everyone to see? Good, OK. So we have a couple of jobs. And the first job that we have, we'll look at is our application. OK, so let's look at our application. So it's HashiApp, right? So this is the big job file if you've never seen one. So this is our starting point. We need to describe our job to run it. So I'm going to run it in the default data center, DC1. The type of this job is going to be a service, right? So I just want to control where it runs based on the count below. Here, I'm also going to be doing live updates in this demo. So I wanted to show you kind of this update. So here, whenever I need to change or roll versions, and that causes the job having to be destroyed and rolled out, this is the interval that we're going to do. So we'll kill, in this case, one at a time every 10 seconds, all right? Because we don't want to drop traffic if clients are coming in and we're in the middle of an upgrade. Here, I'm going to start with 3 instances online. And here, I'm using the exec driver, okay? So this will assume that I'm going to pull a binary from somewhere, or it could be on the host already. And I'm going to call this command. So the command is going to be called HashiApp. The next thing, I need a little bit of environment variables. You see that they're empty here. I need my Vault token. Until there's native integration with Nomad, this is the best you're going to be able to do, all right? Just don't check it in GitHub. The next thing is the address to Vault itself. You'll notice what I'm doing here. I'm using vault.servers.consul because I have Consul running on every worker node, so I'll be able to use the fact that Vault auto-registers itself, okay? So I don't have to go around looking for it. And then the other thing that I'm going to need is my external database. Now, I was a little surprised when I went to do this. I was assuming that I could just register any service in Consul, even one that is not running in my cluster or on any node, but that wasn't actually easy to do. So really what I wanted in this case was a headless service. I want my internal applications to assume that they can ask Consul for my external database, and that actually wasn't quite easy. So I'm going to have to put the database URL there myself. Here I'm specifying the artifact. So here I'm going to be running version 1 of my application, and I'm just going to put this checksum to make sure that I grab the right binary before we run it. The next thing is our resources. A couple of things here. This is going to help the scheduler decide where your workload will fit and give you some type of SLA about what resources you can assume that you can use. One bit gotcha here, mbits, right? So this is my network bandwidth requirement. Most people are setting this to 10 or to 100. If you do that in the 0.4 release, you're going to be in for a classic surprise. Most nodes, especially in the cloud, when you fingerprint them, they come back and say that they only have 100 megabits of bandwidth. If all of your apps say 10 or 100, how many apps are you going to get per node? 1. This is going to surprise you in 0.4 because in 0.4 is when it started to be enforced. So now if things were working before and you upgrade, I guarantee you, you will not be able to schedule more than 1 per machine. So you need to think about that going forward. So here's my hack. I'm saying that my app requires 1 megabit of bandwidth, and it's not necessarily enforced on the server side, so this is OK. What I would like to see here is this be optional. right? Unless I really need to specify my bandwidth, this should just be a default value and just let the operating system deal with it. Here I'm asking for a dynamic port. And then here's where I'm integrating with Consul. So I'm saying the name of my service is going to be HashiApp. And notice the tag. This tag is going to be important because I'm going to use a load balancer that has Consul integration. And based on this tag, it's going to automatically create a reverse proxy with this vhost entry. So hashiapp.com. And then here's my check. So we looked at the code earlier, and I had this health Z endpoint. So this is how we're going to call our health checks in the app. So here's our job. Before I do that, I need my token. Okay? Before I get my token, I need to get a policy, or I need to set a policy of what that token can do. So here's Volt, and here's our application policy. So for app instances in the HashiApp category, they should be able to read their secrets. So this is where my JWT token will be stored under secret HashiApp. And they should also be able to read a dynamic passwording, username and password from MySQL creds, HashiApp. And then it's your responsibility in the app to renew your dynamic credentials, and you need to make sure you have the ability to update the renew on system, all right? Because that's a gotcha. If you don't put that in your policy, you won't be able to refresh your token. So what we need to do now is submit this policy to Volt. Just going to run Volt here just to make sure that status, just to make sure it's up and running. All right, so it looks good. So now we're going to submit this. Bash history for the win. You didn't think I was going to remember that, did you? All right, so now I have the policy in place. So with the policy in place, I can generate a token for the application itself. And I'll have the ability to do all the things specified in that policy. So now I'm just going to do a token create. I'm going to ask this token to use this policy that I just pushed to the cluster. And the name of it is just going to be HashiApp. That's just a display name. So I grab this. I think this is the only time that you see this token. You forget it, you'll be generating a new one, okay? So I'm going to take this token now and just stuff it in my file. Again, don't check your tokens into GitHub. I should do a scan on GitHub to see how many people have done this. All right, so what we're going to do now is we're going to modify the job. So maybe you're going to store jobs like this or generate them on the fly with some kind of wrapper that injects the token as needed. So we're going to stick this token in here. So the app now has the ability to communicate with Volt to grab other secrets. While I'm here, I'm going to go to my external database. So here's all my nodes in GCE, like the best cloud platform ever, plug. Got to do that. All right, so here's my hosted database. Most people get really excited about running a database inside of a cluster manager like Nomad. This is going to make you lose your job guaranteed. It's not only because Nomad currently doesn't have support for like volumes, network attached storage. Volume management is a really, really hard problem, right? It's easy to bootstrap. Yeah, you can run a little script and it's all up, you show your friends. But what happens when the volume gets detached? Who puts it back? Or what happens if the node dies and then you try to attach the volume somewhere else without making sure that when that node comes back, it doesn't reattach the volume? You will lose all of your data. So if you're going to start out with something like Nomad, and you're using MySQL or Postgres, those particular things aren't really great at being moved around, right? Even though you get your replication set up, that was designed in a world where the machines don't get touched. You put them in a cluster manager where start moving things around, you're going to lose your data. If you don't know anything else after this talk, know that part. Do not get excited and spend a bunch of time trying to run databases inside of these cluster managers. Maybe for dev and QA, if you just need something that isn't fault tolerant, you bring up a stack and you tear it down, makes sense. For production, data loss. Okay? So I'm going to run this outside of my cluster. So I'm going to grab this IP address. You guys are like, why do you spend so much time on that? Because I see you people in IRC, and you're like, I lost my data. Nomad sucks. It's like, no, why'd you do that? Don't do that. All right, so I'm going to drop this in here, and we're going to do 3306. So now I know where my database is, right? So our app is almost ready to go here. All right, so now we have our token. We have our policy. One thing that I did before this talk is I mounted the MySQL backend. So if you look at some of the things I need to do here, so I'm adding their credentials, erase those before you guys host my database. So I gave Vault the ability to create users in my database. The next thing I need to do is tell it how to create users. Where is this thing? Here. So this command just says, hey, whenever someone needs to create a role, here's the template you use when you log into the database to create that user and grant the privileges to that user. So I hit enter that to make sure everything is good. All right? So the next thing I'm going to do is just make sure I can actually get my credentials. So I'm going to read from there, and we see it works. So that command forces Vault to go out to my database, connect to it, and grab some credentials. So this username and password, if you're fast enough, you can connect to my database, but haha, you're not that fast. All right? So now we're good to go. Our dynamic environment is set up. The next thing I need is Consul on all the worker nodes, okay? So what I'm going to do there is have a system job. So let's look at jobs really quick. So this is my Consul job. So this is basically going to say, run Consul on every machine in the cluster, right? This is a really handy way of doing it. So the type here is system. And what I want to do here is run the Consul agent on every machine in the cluster. So if I add new machines, I don't have to worry about adding them. This will automatically span out. And then I'm just going to pull the binary for Consul, got the SHA-1, put it on disk, and then run it, okay? And this will connect out to my existing Consul cluster. I'm going to join the cluster. All right, so we're going to run this on every node. So one thing we can do now, Nomad plan. Let's just show that off, right? And he's like, please show plan. I'm going to show plan. All right, so here's the Consul thing. All right, so that's fantastic. That's really impressive. You show your boss, like, we have plan, okay? So you see this thing is going to create 5 instances because currently I have 5 nodes in my Nomad cluster. So if we look at Nomad, what is it, node? Whew, I remember the commands. I look like I know what I'm doing, don't I? Like, feels good. Okay, so now that we have the plan in place, let's go ahead and run it. So we see that the dry run says this should totally work. So let's run this now. Nomad run jobs Consul. All right. So now we get an allocation for each of those instances of the job. And at this point, we should have, if internet's fast enough on my cloud platform, then we should have this running. So Nomad status Consul. Right? So we see that the job is now running on every machine. So at this point, I should be able to join all of those agents to my cluster. All right? So let's do that now. All right, so we join each of those. I know that those are the names of my workers ahead of time. So now if I do Consul members, we see that we have all of those machines attached. So now we can do service discovery locally on every Nomad worker in the cluster. And Nomad knows how to use a local instance of Consul to automatically register our services when we specify our service in our job definition. All right, great. So we're making great progress now. So the next thing I need is to deploy the app itself. Everything is in place for this thing to actually work. So we've already seen the job. We're going to run it. Let's go ahead and plan that again. Jobs, HashiApp. So right now it tells me I'm going to make 3 of these things. There are none of them existing, so it's going to forcefully create these. So let's go ahead and run those now. So we're going to start with 3 instances of them. Nomad run. What is this? Jobs. And we'll say HashiApp. Right? So at this point, if everything is working, these should start running on some of the nodes in my cluster, right? There's only 3 of them. So the scheduler will place them to where they're a best fit. So let's say Nomad status. So at this point, let's go a little bit more detail about this job. We'll see that we have 3 of them running. Now, my app could be running, and since I retry my database connections, I could actually have issues. So how do you find out if you have issues in a Nomad cluster? You want to look at the logs. So in the new release of Nomad, you have the ability, they actually made it a lot easier to get the logs, and you can actually get the logs for a random instance inside of that particular job. So since we have 3 of them, I don't necessarily need to use one of the alloc IDs. I can just use any of them. So what I can use is the fs command. So this fs command will dynamically grab, in this case, one of the alloc IDs from this HashiApp job, and then go and look at the alloc directory. So every time you create a job in Nomad, you end up getting an alloc directory where your binary is put and also your logs, okay? So now if I hit this command, I get to see what my standard out logs look like. So I see the health checks are flowing through, so I think everything is healthy. But I can also look at the standard error logs, right? And most logging libraries actually log the standard error and not standard out. This is why you need both streams. But in this case, you see that my app is starting. I was able to grab my shared JWT token from Vault. I was able to get the dynamic database credentials. I initialized my database, and I bound to the port that Nomad provided me, right? And now I have this background thread that's renewing my credentials at some interval shorter than the least duration. Okay, so my app is running, right? So I'm feeling a little confident here. Now you're ready to get traffic. These are private IP addresses. While you could hit this IP from one of the instances inside of the cluster, this does nothing for outside of the cluster. So let's say curl here, right? We get this hello message. Let me just clear this a little bit. So that works, but who knows what the random port is for all the other instances? We can't be publishing these things because things get moved around. So how do we fix this? A couple of days ago, I learned about a load balancer product called, how many people have ever used this? Is it Fabio? Fabulous. Fabio. So this particular load balancer has native integration with Consul, and based on tags, it will create reverse proxy with all the settings that you need, 0 config. I tried it, and it actually works. There are a few things that work when you first try them. This is one of them, right? So what I want to do is I'm going to use a pattern where I run this particular job on every instance in the cluster. The reason why I want to run this on every instance of the cluster instead of on a separate few machines is that I get a little bit of high availability, and I can take the rest of the nodes and put them behind the load balancer and use my cloud provider, or if you're running your own data center, you can use your high-level load balancer to just send traffic to the port that this is listening on. So I'm going to roll this out to every machine in our cluster. So now we have the ability to do load balancing this way. So we'll do Nomad. Forget the plan thing. I'm sure it's going to work. Fabio. Great. All right, so at this point, we should have this application running on every machine in the cluster. Let's look at status really quick. All right, looks like it's running. And then let's go and check our UI. So I have Consul running. Don't think about hitting it. I'm using a SSH tunnel because I did this before, and then people started like removing services. So it's proxied on my localhost, so put your laptop away. All right, so you can see all of my services are healthy now, right? So Fabio's healthy, Hashi app is healthy. I have all these instances running. So now we should be able to actually use our reverse proxy. So if we come over here to the dashboard, we see that our 3 instances are in place, okay? And also, I have a high-level IP address from native integration with my upstream load balancer. So let's go look at my load balancer really quick. So again, if you look at the infrastructure here, we have a load balancer running on every node in the cluster. We have our app running on a subset of those nodes with dynamic ports, registering themselves to Consul. This is reading that based on tag. Here I get this host. If I come in like with curl and I set the host header to hashiapp.com, I'm going to be routed to this backend. You can do this based on paths, or you can do it based on the host vhost attribute. So now if I go here to my networking stack, and I look at my load balancer, you'll see I have this load balancer called HashiStack in place. And then what I've done here is I just put every one of my Nomad workers here as backends, and they're sending traffic to port 999, and that's the port that my load balancer runs on. So this is just going to pass through the traffic here. And I can also use this port to start to interact with the machine. So now let's just see if this works. And, we need to set the host. Okay. So here we'll set the header, the host header, caps lock. Will be hashiapp.com. All right, so that works. So what we're going to do now is we're just going to put this in a for loop, and we're going to close this out a little bit. So let's just run this in the background. All right, actually I want the version. So we know it says hello, but let's actually pull the version. Got it. All right, so this is great. So we have this full stack in place. So the next thing I want to do is like, how do I scale the application, right? And that's pretty easy. So the whole system is declarative. I go back to my job spec, and I say, HashiApp, I would like to increase the count. So how many should we run? Say a number. 300, no. 300 divided by 10 minus 15 plus some other stuff gets us to 8, okay? So we'll run 8 of these. 300. This guy. All right, so we'll do Nomad run. And this goes out and says, well, a few of them need to be modified, but 5 more need to be recreated, okay? So let's do this again and see what plan has to say about it. So we're going to go back and put this back to 8, from 8 to 3. Let's see what plan does. So the previous experience would be that's how you do it. We'll just run this again to get us back to 3. These things happen pretty fast. So let's say we bump this to 8, and given the new feature for plan, am I typing faster than the internet wants to go right now? Okay, let's put this back to 8. All right, and let's look at what plan has to say about this. So Nomad plan, jobs, HashiApp. So this tells us, hey, you have 3 currently running. You increased the count from 3 to 8, so I need to create 5. All right? So we know that should actually work. So let's just run that again. So these will spin up. And then let's see if they actually come up and get registered. So our load balancer will only pick up nodes that report healthy in Consul. So this is why you need a health check in place. Right? So this tells me 2 of them are failing. So they're probably still initializing, but they haven't been able to satisfy the health check. So they don't get added to my load balancer output. Once they start to succeed, we'll see this number. Oh, so they all are passing now. Now we see that we have 8 in our back end, and we don't have to change any of our upstream clients. So this works. And let's look and see what's happening to our network traffic. Are we dropping packets on the floor? So we were scaling up and down, and the nice thing, we're not dropping any packets on the floor, right? That's kind of important. Dropping packets is bad, okay? Now, the last thing we want to do is scaling out is easy. What about upgrades? Okay, so we need to roll the cluster to a new version. So what we're going to do this now is we're going to modify our job again. So we'll come here. So now what I need to do is manipulate the artifact. So I know I want to go to V2. We'll come here to V2. And I need the SHA for this particular binary. So we're going to change the binary. Watch these Vim skills. Like, whoo! You ever see someone do that for the first time? Like, I don't know how to do that. So let's get this SHA really quick. So I actually have it. So let me grab this. So if you're going to use the exec backend, it's probably a good idea to store the SHA with the binary, so that way you can actually find it. Ask me why later. So ideally in my storage, where I have all of my binaries, I'm storing the SHA along with it as well. So that way, if I have to do a dynamic configuration, the SHA file will pull up and I can bring it down. Well, take your time, internet. All right, so let's just put this in place. All right, so given those 2 things, we'll run our plan again. So Nomad's like, okay, all right, you've changed a bunch of things. And some of the things that you change will require things to be destroyed and updated. Ideally, the artifacts fall in that category. So what we're going to have to do is, based on our update policy, we're going to have to roll through this based on the number you want in parallel. In our case, we're going to do 1 every 10 seconds until we roll out the entire update to every instance in the cluster. So here's what plan is reporting. You have a new SHA, a new binary, and we're going to have to do this rolling update. Are you sure? Like, yes. So we'll run this. And you'll see from the output here that it's going to do these one at a time, okay? So something gets destroyed, and you'll see it telling you when the next evaluation will occur for this particular job. So if you see here, you'll see that the next evaluation will happen in 10 seconds. So that meets our policy, okay? Now, while that's rolling, only healthy instances are being added to the backend. So you guys see 2.0 pop in there? Yeah, so there's one instance of 2.0. So this will continue to destroy. So this is why you need to do clean shutdowns in your application, right? Nomad can't be responsible for that. You've asked it to destroy and add new instances, so your job is to make sure you shut down cleanly so we don't drop any packets along the way. And since we're doing all of those things in our application, Nomad can safely roll out our updates without us being paranoid if users are going to see 500s or other errors. So we'll continue to roll this until we're complete. Let's verify here. So we have a couple more allocations and evaluations to complete. And let's see how far along we are. Let's look at our backends here. And you'll notice that in your load balancer, there's a chance you may have more than 8, maybe less than 1, but that's just because you're going through your loop, but eventually you'll get back to full capacity. So once we're back to 8 here, we can be pretty sure that we're close to being complete. We pop over here, and you can see that we have 2.0 across our cluster. So that's how you use the HashiStack to manage 12-factor applications. Thank you.
For Kelsey? Questions about the HashiStack?
Nomad versus Kubernetes. Woo! Those are two different things. Seriously. I'm going to be hacking with one of the Nomad distinguished engineers over here later on possibly hooking up Nomad to Kubernetes. So what does that mean? What is Nomad in this case? Nomad is a really awesome scheduler, right? It's already proven that it can schedule all kind of workloads. Kubernetes is more of a full platform, right? Not only is it a scheduler, it has 3 of them. It has all these other things, and it's like a foundation for building a platform. So this is why you see things like OpenShift, Deis, and all these things built on top. The HashiStack in this case is more like a collection of Lego bricks that work really awesome. Matter of fact, Volt would be a great backend for Kubernetes secrets. Nomad would be a great scheduler for the Kubernetes platform and for any other platform, right? You could imagine a cloud provider in the future taking Nomad and using it to schedule those VMs that you click on in your cloud platform, okay? So I think they're just two different things, and this is what the HashiCorp team is really good at, right? They build these pieces that you can use. Consul falls into that category. So those are things you actually can't really compare. So when you saw me put together the stack, I had to compose the stack that I actually wanted. And for a lot of people, Nomad itself is the missing piece. They already have something for consensus. So I think it actually is a great place to be in, and we need something across that category. Hopefully that answers your question. Any other questions? There's one here.
Are you failing the health check before you're exiting to minimize the so that Consul will deregister it prior to so basically, yeah, as you're taking one instance out of rotation, like if you scroll right down to the bottom where you've got the block and close line 103, so that's obviously going to close existing HTTP requests, but what's to stop the risk of the load balancer sending new HTTP requests to that instance while it's in a shutdown state?
So what will happen here is the library I'm using called Manners, it's going to reject all HTTP requests. So if I have one in flight and I'm waiting to respond, I'm going to respond 200. The next request that comes in, if I'm in the middle of shutdown, will be rejected.
Okay.
Right? And also Nomad, I'm stopping you. I know what the service is, and I have integration. I can go pull you out as well. Right?
Okay.
So I don't necessarily need to do it here.
Yep.
One thing that I need to do here, though, would be if I don't need that secret anymore on shutdown, just tell Volt, hey, go ahead and get rid of those credentials.
Yep.
And also, yeah, I could also say, if I wanted to, that, you know what, I'm no longer healthy and fell on purpose. Yep. But we don't necessarily need to deal with some of those race conditions, but I do like the idea of throwing away your tokens and telling Volt it's okay to get rid of the cruft.
Okay, cool. Thanks.
Good question. I think I have time for one more question. Oh, okay. And then you.
Hi. You put Fabio and Consul as Nomad jobs, and they obviously take up the network. Those meta services taking up network resource, where you said earlier you had to you had to provide a value, and it would prevent other jobs that you typically want taking those resources. Is that a sensible thing to be for Nomad to be doing?
All right, so I think the question was, I'm using Nomad to schedule some of the cluster dependencies like the Nomad agent itself, right? And I think this is an important thing to do. You want Nomad to be aware of all jobs running in the cluster. So an ideal state to be in is anything that's using any resources the cluster manager should know. One thing I didn't show is that there's a new stats that you can get. So in Nomad itself, you can actually see a bunch of stats about what the node is actually doing. So say Nomad status. I'm going to try to do this really quick. And if I look at one of these, let's see, Consul. And I think, can we do it here? Let's see. So I maybe have to do it on the allocation ID. So let's do allocation status, or alloc status. And then I can do it on one of these IDs. So we'll bring one of the IDs from here. And you can actually see what's being used, okay? So here's all the IPs, ports, CPU utilization, memory utilization, CPU and stats. And ideally, this should help Nomad make better decisions when it's time to kick things off of a server, but you don't want to have it any blind spots. So I think having the stats implementation lets it go and get other services that are running that you didn't schedule. But ideally, I like the idea of having this thing schedule everything so I can kind of know if it will fit or not. Relying on something that was installed backdoor, that might be a bit fragile. And also, using a system job for the Consul agent makes it easy to grow the cluster, because if a new node shows up, I can ensure that Nomad's going to make sure that it's running all of the system jobs that need to be there. All right? So great question. I think I'm out of time. I'll be hanging around in the back, so if you have any more questions or you want to see this demo again, I'll be happy to show you. Thank you so much.